All right, in this video we're going to be talking about applications of exponential problems. So you'll notice that all of these are actually written in exponential form, not log form. It's not because we don't use logarithms. We're going to end up using logarithms in this assignment because anytime we have an exponent with a variable, we're going to have to use a logarithm to solve it. So we will be using logs on the assignment. They're just not log problems, if that makes sense. All right, so some of these formulas should be familiar. You might not have solved with them this way, but you should have at least in earlier math classes when you learned about exponential functions, you should have at least plugged numbers in and gotten results. So the p-value that you can see in all of these problems is the principal, which is the initial value. The R value that you can see showing up, this one doesn't have an R, but in most of these is the rate, which we always, it's a percentage, right? And we always write as a decimal. So if we have 5%, then when we write that as a decimal, that's going to be 0.05. If we have 1.8% as a decimal, that's 0.018. So we'll just make sure that when we take a number that's a percent and we write it as a decimal, we take wherever the decimal place would have been, we move it 2 spots to the left. One of the problems, compound interest has the n value in it. The n value represents the number of times per year. And I guess I said per year, technically it's per whatever time period is given in the problem. It is often per year, but it doesn't have to be. So I'd say number of times, for example, if they said semi-annually, they mean twice a year. If they said it happens quarterly, you would think 4 quarters make a whole, so that'd be 4 times a year. If they said monthly, that'd be 12. If they said weekly, that'd be 52. Daily would be 365, that sort of thing. So based on the number of times they say in the problem. Anytime something is compounded continuously, we know to use this. Continuous exponential growth is kind of like the like these two are related. You have compound interest problems, and then you have compound interest problems where they say the word continuous. You also have like exponential growth and decay problems, and then you have the version where they say continuous exponential growth. And so anytime they're talking about something that is growing exponentially and they use the word continuously, instead of using this and having the rate of R, we switch over and E is going to be what we use instead. So this E does not represent a variable, that E is that button on your calculator. And then for half-life, T is the amount of time, and actually T in all of these is the amount of time. Typically it's in years, but if the context of the problem says days or months or weeks, then that's what they're talking about. And then H is how long a half-life is. So, example number 1. Gregory Marie invests $300 of his tutoring money into an account with a 6% interest rate, making no other deposits or withdrawals. What will his account balance be after 20 years if the interest is compounded semi-annually and monthly? So it says that we have compound interest, which means that we are using this formula right here. $300 is that amount that he's starting with, and so I know I'm going to say y equals 300 is our principal amount. 6% interest rate means that R is going to be 0.06. The number of times per year, they're asking us to do the problem twice. So semi-annually and monthly means that we're going to do n equals 2 and n equals 12. So number of times per year semi-annually, 2. And then I'm going to set up the problem again because we're also going to be plugging in 12. And then it says the balance after 20 years, so t is 20. So times 20 times 20. All right, so beginning, and I guess I didn't write that down, I could do that. Our beginning value, sorry, the intercom went off and I tried to pause the video and I did, but now I don't remember what I was saying. So anyway, we plugged each of those values in. All right, now this is a problem that I could have asked you before pre-calc. This is very straightforward. You plug it into your calculator, you get your answer, you're good to go. So 301 plus 0.06 divided by 2 to the 2 times 20. So in 20 years, if the interest is compounded semi-annually, so if it's compounded twice a year, then your $300 would become $978. Or not yours, I guess, Gregory Marie's. So $978.61. And then if I want to do it for monthly, it would be $993. So it's the more often the interest is compounded, the more money you make. All right. The next question is the part of the question that we're really getting at, and these are the types of questions that we would like to ask that we could not answer when we were first learning these formulas. They are questions that now that we have gone through this unit, we actually know the mathematical processes to solve them. So here it says, when will Gregory Marie have $5,000? So we do have two different situations, and so we're going to have to do this problem twice to figure out the answer in each situation. But now we're saying that the ending amount is 5,000. So 5,000 equals 300. 1 plus 0.06 divided by 2 to the 2, and this time we're going to say t because we no longer think that it's 20 years. So that's one version of the problem. Here's the other one where we are compounding monthly. Okay, so the first step in both of these problems is to divide that 300 over to the other side. Now you can figure out what that decimal is, write it down, store it in your calculator, whatever you want to do. What I typically do is I reduce the fraction a little bit just to make it easier to write, and then I just write it as 50/3 because I don't want to have decimals that have to be stored in my calculator. Sometimes I will check to see if this part in the parentheses needs to be stored or if it could just be written down. Yeah, that's a nice one, 1.03. Let me go ahead and write that. Nope, that's not 1.03. Let's try the other one. Oh, that's not bad either, 1.005. Okay, so at this point we have an exponential equation that needs to be solved. And so I have a variable in the exponent. I cannot make those bases the same, and so that means I need to either Tootsie Roll the problem to write it and convert it into log form, or I need to log each side. So since I have two problems, I'm just going to do one each way. So if I do the Tootsie Roll, I would say log base 1.03 of 50/3 equals 2t. And then I can go ahead and just divide by 2. For this one over here, I'll use the other option where we're going to log each side. So since this one has a base of 1.005, that's the log I'm going to use. So I'm going to say log base 1.005 of the right side, log base 1.005 of the left side. So we have log base 1.005 of 50 thirds equals 12t, and then I'll go ahead and divide by 12. Okay, so we can go ahead and plug these in. So 47 years. That's quite a bit of time. And then for the other one, I'm going to type 12 down here, 1.005. Also 47 years. Just 47 and a half as opposed to 47. Saves you a little bit of time. All right. For the next example, Jayla has decided to invest $300 into an account as well, and she did win this money by doing a math poetry contest that she won. She searched high and low, and she found an account which compounds the interest continuously, which is better. So compounding it twice a year or monthly, but compounding it continuously means you're doing it all the time, so your money is accruing interest faster. So she does have the same interest rate as Gregory Marie. When will Jayla have $5,000? So since she is compounding continuously, that means we're going to use this formula. So y equals PE to the RT. So we said we're checking to see when she has $5,000. She starts off with the same amount. She had the same interest rate, so that's still 0.06, and the time period is what we're solving for. So just like before, we're going to divide by 300. So 50 thirds equals e to the 0.06 t, and you can Tootsie Roll this and turn it into log form if you want, or you can log each side. I'm going to go ahead and log each side. So the log that has the base that I want would be a log with a base of e, which is ln. So I'm going to go ahead and ln this side and ln that side. And so I have ln of 50 thirds equals 0.06 t. And so I can go ahead and divide by 0.06. All right. So ln of 50 thirds divided by 0.06. So if it's compounded continuously, she'll have $5,000 in less than 47 years, so she's a winner. All right, you guys, I know you're sad, but that's the end of the video because I have to go get my nails done.